So let's start. Ayman, are you there?
Yes, sir.
So you have seen that when primary alcohol oxidizes with a mild oxidizing agent, it will be converted into aldehyde. But when we talk about secondary alcohol, it will be oxidized into ketone. But tertiary alcohol cannot be oxidized. But if you still want to oxidize it with a very strong oxidizing agent like acidified KMNO4 and at elevated temperature, then CC bond will break. So I'm going to write a point about this. Please write it. Wait a minute. Why it's not working? Okay. So please write it. Tertiary alcohol do not undergo oxidation reaction. Tertiary alcohol do not undergo oxidation reaction under a strong reaction condition such as a strong oxidizing agent and elevated temperature, very high temperature, and at elevated temperature, cleavage of C bond will take place. Cleavage of various CC bond takes place, but it will not be oxidized directly into aldehyde or ketone or carboxylic acid. So keep it in mind. Now there will be another reaction. So please write it and let me know when you are done with this.
Yes, sir.
Very good. Now I'm going to write a point which is very easy to understand. Then I will explain. When we use vapors of primary alcohol, primary and secondary alcohol, primary or secondary alcohols, or when the vapors of primary or secondary alcohol passes through, or we can write, or passed through heated copper at 573 Kelvin. At 573 Kelvin, dehydrogen takes place. Dehydrogenation takes place. And an aldehyde or ketone formed, or a ketone is formed. But in case of tertiary, it will undergo dehydration. I will give example. But in case of tertiary, again it is not oxidized. Alcohols undergo dehydration. So I'll give the example. First of all, you are going to write it, then I'll explain it.
Done, sir.
Ayman, what about you?
Almost, sir. Yes, sir.
So,
Done.
okay. So basically, I was thinking, will you be comfortable apart from assignment? I will be adding some questions, important questions of organic chemistry in your WhatsApp group, and I will be only sending if you are going to solve it and send it back to me.
Sure, sir.
I mean, what about you?
Yeah. Yes, sir.
Okay, thank you. Now I'm going to explain it. So basically, when you are going to mix or take primary alcohol and you are going to pass it through heated copper, basically copper at 573 Kelvin. So basically what happens here, it's very easy. This is hydrogen, this is also hydrogen, and this is OH. So what happens here? Dehydrogenation takes place. Hydrogenation, that means addition of hydrogen. Dehydrogenation, that means removal of hydrogen. So this hydrogen and this hydrogen will be removed. So what it will be? RCH4 aldehyde. It will be directly primary directly converted into aldehyde. Now, if you have secondary alcohol like this, what happens here? It's very easy. Wait a minute. I'm going to R dash, write R dash on the right hand side. This will be R dash and this will be OH. So if you are going to again pass it through, this should be in vapor 573 Kelvin. So what happens here? It will be directly converted into ketone RC double bond O and then R dash. This H and this H will be removed. That means elimination will take place. Now, if the alcohol is tertiary, if the alcohol is basically tertiary, you can see, as you already know what is tertiary alcohol. Tertiary alcohol is the one which is connected with the tertiary carbon. So here, dehydration will take place. That means a removal of water. That means basically OH from here and one hydrogen either from here, here, or here, wherever you want, you can take it out. So it will be basically the product will be if you are going to pass it through copper at 573 Kelvin. So what will happen? I'm going to write CH3 and then C and then CH3. That means basically I just took hydrogen from here. So there will be double bond CH. So this is how the reaction will take place. If you still have any doubt in this, please ask me. Then we are going to study about the electrophilic aromatic substitution.
Done, sir.
I mean,
Yes, sir. Done.
Very good. So this was about the chemical reaction of basically alcohols especially. Now we are going to learn about the electrophilic aromatic substitution. Aromatic substitution. That means basically we are going to study about phenols, chemical reaction of phenols. And in this reaction, we are going to study the first reaction, nitrogen. And everyone knows what does this means. This means basically addition of nitro group. So how we are going to add nitro group in a phenol? We have a phenol, you can see benzene OH. And when you are going to pass it through or dip into dilute HNO3, there will be generation of an electrophile, that is NO2 plus, and it will be attacking on two positions. There will be two products possible with respect to OH. It will be on ortho or either on para. There will be no attachment on meta. Everyone know why it is so. Why NO2 cannot go at para? Sorry, meta. Can anyone tell me? I have written this product. This is ortho, this is para, and this position is basically meta. Why NO2 is not attached at meta? Basically, when you are going to do the resonance of OH, there will be no negative charge on meta position, either this or this. That's why the negative charge revolve here, ortho here, here. That's all. Got it, Rim?
Yes, sir.
Ayman,
Yes, sir.
can anyone tell me which one is more stable? Or we will talk about it after some time. Please write it. Then there will be ortho and para isomers. This can I say this both are isomers? Same chemical formula, different arrangement.
Yes, sir.
So I'm going to write a point which is very important. The ortho and para isomers can be separated by steam distillation. Steam distillation. So I think you both of you know what is steam distillation. Let me know when you are done with this. Both of you done with this?
Yes, sir.
Very good. Now see, they can be separated by a steam distillation. Basically, this O-nitrophenol, O-nitrophenol is steam volatile. Wait a minute. Is steam volatile due to intermolecular hydrogen bond. Sorry, intramolecular hydrogen bonding. While para-nitrophenol, so everyone know which one is para and which one is ortho, is less volatile due to intermolecular hydrogen. Intermolecular hydrogen bond, which causes association of molecules. So both of you tell me that, wait a minute. Both of you tell me, are you aware of this p-nitrophenol and o-nitrophenol, orthonitrophenol and para-nitrophenol? Ayman and
Yes, sir.
Rim? Now see, basically this orthonitrophenol is intramolecular hydrogen bonding. That means the hydrogen bonding will be in the molecule, inside the molecule. See, this is the molecule and this is O, this is double bond O. And you can see there will be hydro OH group like this. So it has hydrogen bonding inside the molecule, in the same molecule, that is intermolecular intramolecular. This is intramolecular H bond, H bond. But when we talk about or para-nitrophenol, you can see para-nitrophenol. This is OH, and I am going to draw a structure. This is double bond O. This is O. And you can see the another molecule of para-nitrophenol, and there will be OH. So there will be hydrogen bonding in two molecules. That means basically intermolecular hydrogen bonding, and you can see that this is association. Basically, due to hydrogen bonding, this two molecule becomes one. So it is basically more stable. That's why less volatile, and due to intermolecular hydrogen bonding, association takes place. So please write it. Wait a minute, please. Right. Let me know when you are done with this.
Yes, sir. Done.
Rim, are you done with this? Rim, are you there? Am I audible? Amen. Amen, am I audible? Madiha,
Yes, sir.
when did you join? I didn't basically.
Sir, I joined a while back.
Okay. So, are you done with this?
Yes, sir. I sir. Okay.
Okay. Now see, when we treat phenol with concentrated nitric acid, nitric acid, nitric acid, phenol is converted to 2,4,6 trinitrophenol. So trinitrophenol, also known as picric acid. Picric acid. So if you are going to use dilute HNO3, you will get two products, that is orthonitrophenol and paranitrophenol. And if you are going to use concentrated nitric acid, this is OH, and this is, you are going to treat this with concentrated HNO3, then you will get 2 comma 4 comma 6. That means with respect to OH, you have NO2 at this second position, then third, it's third position, but we need to, this is the fourth position, NO2, and this is the sixth position. So this is known as, its name is basically picric acid, and its IUPAC name is 2 comma 4 comma 6 trinitrophenol. Please do write it. Let me know when you are done with this. Madiha,
Sir, I'm writing, just
Yes, sir.
one
Done.
minute.
Okay. Take your time, Madhya. Madhya, you were absent continuously. Hmm.
Yes, sir. I was having my midterm, so that's why.
Okay. So please write it.
Done, sir.
Very good. So basically nowadays picric acid, the yield is not so good. So I'm going to write for this reaction the yield or the product is not good. The yield is not. The yield is poor. Okay, is not very in good amount or good quality. Picric acid is nowadays is prepared by treating phenol first with concentrated sulfuric acid, which converts it to phenol 2,4 disulfonic acid. Disulfonic acid, and then with concentrated HNO3 to get picric acid. To get picric acid. So my question is that can you write a reaction for this? Basically, there will be two reactions. Can you write the reaction, Ayman and Madiha?
Yes, sir.
Okay, please do write it. Are you done with this?
Yes, sir. Now.
I mean, see, I'm going to write the reaction first. Picric acid is now prepared by treating phenol first with concentrated sulfuric acid. So phenol is going to be treated with concentrated H2SO4. Then you will get phenol 2, 4. That means basically this OH with respect to this 1 and then 2 SO3H and then 3 and then 4. This is 2, 4 sulfonic acid, disulfonic acid, which on treatment with the concentrated HNO3 will give you, and the rest will be in byproduct OH 2, 4, 6. This is the 2, this is 3, 4, and this is 6. This is picric acid. Please write it. Then halogenation will come, and then there will be some name reaction like Colbase reaction, and then remertiment, then oxidation, reaction of phenol with zinc. Yes. Let me know when you are done with this. Ayman, are you done with this? Madhya, your reactions are correct or wrong?
Sir, I got them correct.
What you just said?
I got it correct, sir.
Okay, thank you. Ayman, are you done with this?
Yes, sir.
Okay. Now see, the next reaction type is basically halogenous, and everyone knows what does halogenous means. Addition of halogen, and the reaction will be with phenol. So when you are going to treat Br2 in the presence of carbon disulfide CS2 at 273 Kelvin, that means cold, 0 degree centigrade, there will be two products possible, one at ortho with respect to OH and one at para with respect to OH. Now you can see, can you tell me which one is minor and which one is major? So this will be minor and this will be major product. So please write it. This is the A reaction and the B reaction. B I will be writing soon. Are you done with this, Madhya? Amen. Please do respond.
Yes, sir.
Yes,
Madhya,
sir.
are you done with this? Okay. Now see,
Yes, sir.
when thank you. When phenol is treated with bromine water, when phenol is treated with bromine water, then 2,4,6 tribromo is formed as white precipitate. Can you write the reaction, Ayman? So the reaction is very easy. When you are going to react phenol with bromine water, that means basically Br2, then product formed will be, you can see with respect to OH, this is the second position, this is the fourth position, and this is the sixth position. Along with 3 HBr will be released. So basically this is 2,4,6 tribromo phenol. Tribromo, I didn't write phenol here. I forgot to write it. Let me know when you are done with this, please. Ayman, are you done with this?
Yes, sir.
Okay. So this is the reaction for halogenation. Now we are going to study another type of reaction that is basically also known as coal-based reaction. Coal-based reaction. So if I write reaction, can you make sentence? Ayman, Madiha, if I just wrote this reaction, like you can see, phenol is treated with bromine water, then it will give 2,4,6 tribromophenol. So can't you make a sentence with this reaction? Can you make a sentence with this reaction, Ayman? Or should I write the sentence also?
So when phenol is treated with coals,
Oh, oh, no, no, no. I didn't write any reaction. Are you talking about this coal base?
yes, sir.
I couldn't get you. See, coal base reaction. So I'm going to basically it is a name reaction. See what happens here when phenol is treated with when phenol is treated with sodium hydroxide, then phenoxide ion form, phenoxide form. This is phenoxide, ON. Now, when this phenoxide treated with carbon dioxide, which is a weak electrophile, which is a weak electrophile in the presence of acid, then we will get a product that is known as 2-hydroxy benzoic acid. There will be OH and there will be C double OH. So its name is basically 2-hydroxy benzoic acid. And its common name, you have already seen this compound in this chapter, salicylic acid. Salicylic acid. So both of you can make easily a sentence about this reaction. So I should not write the sentences about this when phenol treated with sodium hydroxide, then phenoxide form. And when this phenoxide reacts or treated with carbon dioxide in the presence of acid, we will get 2-hydroxy benzoic acid. You can write this, right? Please tell me, or if you are unable to write the sentence about this reaction, then I will write definitely.
Yes, sir. Can you write it, please?
Okay, no problem at all. So basically, phenol is treated with sodium hydroxide, then phenoxide ion is formed, which is more reactive than phenol towards electrophilic substitution. Electrophilic substitution with carbon dioxide. Then ortho hydroxy benzoic acid is formed. So basically up to this you can see phenoxide ion is formed, and this phenoxide ion is more reactive than phenol towards electrophilic substitution CO2. Basically this phenoxide ion is treated with CO2 and we will get the main product hydroxy benzoic acid. Please write it. Let me know when you are done with this.
Done, sir.
Very good. Ayman,
Yes, sir.
are you done with this? Very good. Now the come to the next reaction, which is basically Remer-Tiemann reaction. Remer-Tiemann reaction. To see what is this Remer-Tiemann reaction. So basically, phenol is treated with just focus here. Phenol is treated with chloroform in the presence of aqueous sodium hydroxide. Then there will be an intermediate form. This is an intermediate O minus Na plus CH Cl2. This is an intermediate. After which a CHO group, again treating with NaOH, sodium hydroxide, CHO group will be introduced on ortho position. You can see this is, and this will be treated with acid. Then we will get salicylaldehyde. This Na will be replaced by H, and this we will get salicylaldehyde. Now I am going to write a sentence about it. On treating phenol with chloroform in the presence of sodium hydroxide, a CHO group is introduced at ortho position of benzene. Benzene ring. This reaction is known as basically Remer-Tiemann reaction. This reaction is known as phase drive. Let me know when you are done with this. Are you done with this?
Done, sir.
Very good. I'm
Yes, sir.
done.
Yes.
Now the next type of reaction is basically reaction of phenol with zinc dust. So basically, this zinc is reducing agent, you can say. If we have phenol and you are going to react this with zinc, what it will do, just take O from phenol and it will reduce it to benzene. So we can write phenol is converted to benzene. Phenol is converted to benzene on heating with zinc dust or zinc. Please write.
Yes, sir. Done.
Very good. You are also done with this, Madiha. Madiha.
Yes, sir. 1 minute. Done, sir.
Very good. Now the last type of reaction comes, that is basically oxidation. And see how phenol is oxidized. So it's very simple. Oxidation of phenol. Basically, we use chromic acid produces a conjugated diketone known as benzoquinone. Known as benzoquinone. So this is your phenol. This is going to be treated with Na2Cr2O7 in the presence of H2SO4, then benzoquinone.
फ्यूचर ट्रेडिंग अगर इस तरह से हो रही है कि आपने फ्यूचर में कोई खरीदो फरोख्त का मामला डन कर लिया,
Ayman,
Yes, sir.
very good. Now I'm going to give you some question. Madhya, are you done with this?
Yes, sir.
So basically, question is based on nitration. Write the structures of the major products expected from following reactions. पहला जो है मोनोनाइट्रेशन कराना है of 3-methyl phenol. Please do this. Can you solve this?
So I'm trying.
Okay. Should I explain? Madhya, are you done with this?
No, sir. Can you explain it?
Okay, see, it's very easy. You knew that. You already know that basically how phenol converted into. This is yours. How phenol can mononitration. You know what does mono means? Only one nitro group. So dilute HNO3. So what happened there? So one nitro group, that means mononitration took place. This is orthonitrophenol and this is paranitrophenol, right? Aman,
Yes, sir.
This is mononitration. Mono means one nitro group added. Now the question is 3-methyl phenol. So see, this is phenol, and with respect to this, since it is a functional group, 1, 2, 3. Methyl is there. Methyl is connected with this. This is CH2, and we need to introduce one nitro group. So it will be dilute HNO3, and with respect to this, we will get this is OH, and this is CH3. We will have NO2 added at ortho and NO2 added at para. So two products we will get. This is how this is called basically mononitration. Are you getting my point? So this is the reaction. This was I already told you. Yes or no? Please do write it and let me know. Then we will continue from here in the next class. Both of you free on Friday?
No, sir. Sorry.
Okay, no problem. So when you are free in this week? Because
So you can take it during a weekday, any weekday.
weekday, that means Thursday, tomorrow, right?
Yes, sir.
What about you, Madhya? Is there any class of yours by tomorrow?
Sir, tomorrow I have physics class, but like it
At
depends.
which time?
If you, it is from
At
6:30 to 8 only, the same time as this class.
6:30 p.m. to this time.
Yeah, the same time.
Okay, okay. Okay, I will talk to the management team and will say, okay, if there will be any class, you will be informed. If there will be no class, you will not be informed.